The second half of 7.5 is about solving the log equations. Now we've really done these already, right, in 7.3. The only thing we're going to change is maybe we have to use the log properties in order to simplify. So use the log properties of logarithms to combine all logs into a single log, and then rewrite as an exponential expression. And I went ahead and wrote our rewriting, our rule for rewriting here, because that's what we're going to be using. So, you know, if I'm in a classroom, which I am not, but when I am, and we're doing these problems, I always write this like at the very top of the board so we can see it. What we need is we need log equals number so that we can rewrite it as an exponential. Okay, quick warning though. Logarithms only have a domain of 0 to infinity, not the whole real line. So if you try to plug in log of 0, domain error, because you're asking what power do I need to raise something to turn it into a 0. So how many times would I multiply something by itself to get 0? Well, obviously, there is no such number, right? There's no number of times you could multiply something by itself to get 0 in the end. And then same thing with negatives. So as long as a is positive, no amount of multiplying a positive number is going to turn it into a negative number. So 0 to infinity is our only domain. And for this reason, we're going to need to check our solutions to make sure they're valid. This is like when we did radical equations and we had to look for extraneous solutions. Same sort of idea here. Okay. So solve the following if possible. Give both exact and approximate solutions. So there are going to be like 3 types of equations. One of them is going to be where the logs are adding, one of them is going to be where the logs are subtracting, and then the last one is going to be where the logs are on both sides. So let's just do 2 examples of logs that are adding. Okay, so log base 2 of x plus 7 plus log base 2 of x plus 8 equals 1. Now when I see this, I know that I need log of something equals number, so I'm going to combine the logs using that the sum of logs is a log of product. Okay, so I actually have log base 2 of the first argument times the second argument equals 1. And now we have log equals number, and I'm going to rewrite it. So log equals number and rewrite. So now we can rewrite. For the logarithm, the base is what I'm raising to a power. The log spits out a power, and it's equal to what's inside of the logarithm. So I get this. So 2 to the 1 equals x plus 7 times x plus 8. This is quadratic, which means we're going to set it to 0, try and factor. If it's not factorable, then we'll use the quadratic formula. So 2 is x squared plus 15x plus 56. Is that right? I never remember 7 times 8. That's pretty bad. Yeah, 56. Okay, I get this. Subtract 2. You have x squared plus 15x plus 54. So to factor this, I need 2 numbers that multiply to 54. But add to 15. So I don't know factors of 54. Oh, 6 and 9 would work, right? Here I said I didn't know factors of 54, and I did. Okay, so 6 and 9. So you rewrite your middle term as plus 6x plus 9x plus 54. Factor by grouping. We have, from the first two, I factor out an x. That leaves me with x plus 6. From the second two terms, I'm going to factor out 9. That leaves me with x plus 6. Then I factor out x plus 6. From the first term, I'm left with x. From the second term, I'm left with 9. So now I have a product of two things equaling 0. One, the other, or both is 0, so I set them each to 0. So either -6 or -9. So I think back here, by the way, we did quadratics in maybe 2, 3, I think. Okay, so I've got two possible solutions. Before we circle one of them, I need to plug these back in to my original equation. So -6 plus 7 is positive, and -6 plus 8 is positive, so I really can use -6. For -9, let's see, -9 plus 7 is not bigger than 0, so I cannot use the -9. So my only solution is -6. Okay. Oops. Only solution then is -6. Now, this was a lot of individual steps, but let's look. This is section 7.4. From here to here is section 7.4. From here to here is section 7.3. The rest of it is chapter 2. The only thing that's actually new for this unit is these steps. 2 steps. The rest of it is stuff we've already been doing. So I have a sum of logs. That's a log of product. Now I can rewrite it as an exponential. Solve what results, which in this case was something quadratic, and then check your solutions to make sure that they're valid. And that's solving when they're adding. Let's look at one other one, solving with addition. So this one is log base 7 of x plus 2 plus log base 7 of x plus 2 equals 2. Your bases have to be the same in order to combine them. In this case, they are. So this is log of, so a sum of logs is a log of product. So instead of adding the logs, I'm going to log the product of the things inside the logarithms. Equals 2. Now I get to rewrite. So the base is 7. The exponent is 2. What comes out is x plus 2, x plus 2. Right? So rewrite. So combine. Rewrite. Quadratic. All right. So 49 is x squared plus 4x plus 4. Make sure you're careful about your squaring. And 0 is x squared plus 4x minus 45. So if I want to factor, I would need two numbers that multiply to -45, but add to +4, which would be 9 and -5. Now, because the leading coefficient is 1, I know that this is just going to factor with these two numbers. So this is just going to be x plus 9, x minus 5. Since you have a product of two things equaling 0, you set each of them to 0. That's only true for the number 0. You get -9 and +5. So for the first one, -9 plus 2 is not greater than 0, so I can't use -9. The other one, 5 plus 2 is bigger than 0, so I can use 5. All right, so solution is 5. Great. So when you're adding logarithms, you turn it into multiplication. It's pretty much always going to end up quadratic, which means you'll have 2 solutions. You'll have to check which one to keep. It is not always the case that you always throw just one of them away, nor is it always the case that you throw away the smaller number. It just happened to be on these 2 examples that that's what we did. You can have a log with like 2 solutions, that would be okay, or no solution.